Hello and good afternoon, CTS267 Section 840 students for the Spring 2017 semester at Anne Arundel Community College. This is the CCNP TSHOOT course, and this afternoon's video tutorial is going to be our tutorial and solution set for challenge number 12. This is going to be our fifth and final troubleshooting scenario with the PILE Forensic Accounting Ltd company. And this one is actually one of the more difficult ones to work through. So let's go ahead and dive in here, and it's difficult for a number of reasons. And if we take a look at the scenario, you can see that Carrie, the customer engineer, was concerned about lack of reliability, and they've added in a second head-in router. So now they've got two head-in routers, HQ0 and HQ1, and traffic goes through HQ1. If it fails, all internet connectivity for network end devices is lost. So we need to resolve this issue and make it so that we've got some redundancy here. And Carrie must have access to all network devices via Telnet, so she uses PC1. Now it's interesting, this comment here that she must have access to everything via Telnet and she's going to be using PC1 is that we can actually console onto these HQ routers, right? They give us a hint here when you're testing IP connectivity failovers to shut down HQ1's Ethernet 02 interface, and then we'll see whether or not we have connectivity. So let's go ahead and do this. Let's confirm the problem, right, following our troubleshooting process. Let's go on to HQ1, go from user exec to privilege exec. We'll put our password in, which is probably C1SC0, and let's say show IP interface brief, and there's Ethernet 02, right, this 209.165.201.6, and that's probably the address that we're appeared on. If we get a show run section router BGP, we should see the neighbor statement, and yeah, 209.165. So here is our connectivity to the ISP. So let's get into global config, interface Ethernet 02, and actually let me make sure we've got PC1 up here, and let's see if we've got that always popular 209.165.200.129. Alright, so there it is. So that's an address that we can ping that's out on the internet. Now, let's go ahead on HQ1 and shut Ethernet 02 down. And so you can see that the interface has gone down. If I were to say do show IP BGP summary, you can see that we are in the idle state now with our eBGP peer. Now this 10.106, we know that this is an iBGP peering that we have going between HQ0 and HQ1. So now we're idle here. Let's go back to PC1, and with that interface down, let's see what ends up happening here. And this looks like it's going to confirm the problem that there is no failover taking place. So what if we were to trace? If I were to say trace to 209.165.200.129 numeric, we get to 10.106, which is going to be, interestingly enough, I believe that's actually the HQ1 router has an interface to show IP interface brief. Sorry, that's 10.107. So the 10.106, so it looks like we're still coming to HQ1, and then HQ1 looks like it's shipping it back over here to HQ0. And again, right now we're just confirming what's going on, and that is correct. And it looks like we're also doing NAT here on these head-in routers, which also makes sense. And again, you see we get to 10.1, let's say Control-Shift-6. So we get to 10.106, but not before the traffic comes into 10.107. So let's go ahead and leave that. We're going to leave the interface down right now on HQ1. And so when we look at our diagram and when we read the description, it's clear that the traffic exits this way primarily, and that that's not a problem. And when this is down, we need the traffic to exit through HQ0 and to successfully get out. So let's take a look at, again, they added this router in, right? So it could be something to do with this router. It could be something to do with our IGP. So we'll take a look at the IGP because right now traffic is coming to HQ1 even though this interface right here has been shut down. So we're probably not tracking that interface. And we're definitely not running the IGP on that interface, so it's possible that right now the IGP is just letting the traffic go up to HQ1 and then that's coming back down to HQ0. So let's clear this out here. So let's start our investigation on HQ0. So let's first go ahead and say show IP BGP summary, and let's see, do we have a BGP peering? And we do, and it looks like we're receiving 7 prefixes. So if I wanted to specifically see, well, actually we don't have the soft reconfiguration inbound set up. If I wanted to see, and again, router BGP 65000, do show run section router BGP. So the neighbor's 209.165.200.5, and I could say soft reconfiguration inbound, right? Now, the reason I want to do this, and I'm going to run the command, it's going to fail initially. I'm going to go ahead and reset the, I'm going to do a soft reconfiguration here. But first of all, if I were to say, do show IP BGP neighbor 200.165.200.5 received routes, I can see exactly the NLRI, or that network layer reachability information that's being received from the neighbor, right? And it looks like we didn't have to clear the soft reconfiguration inbound, because typically when you set that soft reconfig inbound, you need to do a clear IP BGP star in or a star out. Or actually star in, telling your neighbor that you're requesting, like, hey, send me your adjacency rib out, and I'm going to go ahead and then I'm going to keep a copy of that here so that I can reference it and take a look at it. And so these are the received routes. If I wanted to see the routes that I'm sending, right, I would say advertised routes. And so on HQ0, you can see here we've got a rib failure, and again, this is an IBGP learned prefix that we're learning from our neighbor 10107, and it appears that this is going to be the public address space that's been allocated, and so this is probably the addressing space that's being used. Let's confirm that. If I come over here to HQ1, and the reason that we saw that, do show run router BGP, do show run section router BGP, and we know that the network statement here is showing that 209.165.200.249, right? So we're advertising this network out. If we took a look at our NAT, right, because again, we're not using that exit interface, do show run include NAT, we can see that we've got this NAT pool created. It has a single address in the NAT pool, right? We have a corresponding network statement, but do we have an interface? So if I was to say do show run or do show IP interface brief, do we have any interface that's a 209.165.200 in the 249 range? We don't, right? So remember with BGP, if I was to say do show run include route, what do we have? Well, we have a route, a static route pointing to null 0, and it is a /32, right? So it's a host route, it's a /32, and this just happens to be, this just happens to be the same route that matches our network statement in BGP. Now remember, in order for BGP to be able to advertise NLRI or originate NLRI, we must make sure that this statement is an exact match to the network that we wish to originate. And as you can see here, what I mean by exact match is prefix and prefix length must match exactly, right? It's got to be an exact match. If it's not an exact match, BGP is not going to advertise that out. So let me go ahead and clear the screen here. And to show you that, right, let's do just a quick command line look here on two 1841 routers. and they're both running BGP. If I were to say show IP BGP summary, you can see here that we've got a neighbor relationship. However, no prefixes received, but that's okay, because again, any integer here indicates that this peering is up, right? So it means the peering's up. We just haven't exchanged NLRI. Now on this router, show IP interface brief, you can see that I have a couple of loopback addresses, loopback 0 and loopback 1. So if I were to go into router BGP1 and say, whoops, sorry, let's get in global config first, and say router BGP1, and if I was to say network 1.1.1.1 mask, and it's a /32, and say 255, 255, 255, 255, I've just originated this network. Now let's come over here to, and where did router 2 go? Hold on one second. We had router 2 here, and let's see if I misconfigured this here on this router. Show IP interface brief, and I apologize, we had a router 2 and it is gone. So let's see if we can get router 2 back here real quickly. And we're getting a connection refused. Alright, so here's what we're going to have to do. Let's improvise, because router 3 is there and it is operational. Router 2 actually disappeared. So let's go ahead and get into global config here. We're going to say router BGP 3, and we're going to say neighbor 192.0.2.1, remote AS is going to be 1. And let's come over to router 1 and let's add that into the configuration here. So we'll say neighbor 192.0.2.3, remote AS is going to be 3. And we should have a peering that comes up any second now. There we go. And so now what we want to do is we want to say do show IP BGP summary. And you can see we've got a peering here with 192.0.2.1, that's router 1, and we've received a prefix. So if I say do show IP BGP without the summary, this is going to show me the NLRI that I'm receiving, right? Again, because the network statement over on router 1 is an exact match for that loopback address, right? And if it's not an exact match, it's not going to work. If I said do show IP interface brief, and you can see here we have loopback 1, which is 11.11.11.11. If I say do show run interface loopback 1, you can see it's a /24, right? Whereas loopback 0 was a /32. So if I add a network statement that says 11.11.11.11, or I actually will say 11.11.11.11, and we'll do a mask of 255s. If I do this, is that going to originate the NLRI? Well, let's come over to router 3 and let's check. Let's say do show IP BGP. And no, we don't get it. Well, maybe it's just that the scanner hasn't run and the update hasn't been sent out. Okay, it's possible. Let's say do clear IP BGP star outbound. Right? So are we originating that NLRI? Let's check over here again. No, it's not. And the reason it's not, and what we could easily do to check again, is say show IP BGP neighbor 192.0.2.3 and advertised routes. So that is all we're advertising. So again, it's not that the update's being lost. It's not that, we don't have connectivity. The BGP peering is not working. It's none of those things. It's that in order for BGP to be able to originate the NLRI, it has to be an exact match for the network that we're trying to originate. So let's go ahead and fix that, and let's pull this back here. We'll do a Control A and say no network 11.11.11.11 with a /32, and now let's put the correct network statement in there. And what would the network, remember it's not the exact IP address, what would a /24 network be for 11.11.11.11? Exactly, it would look like that. So let's go ahead and say 255, 255, 255.0. Now I'll come over to router 3 And let's see, do we have to give it a little kick? We don't. And take a look. Now we're advertising that network 11.11.11.0/24, right? Because again, it has to be an exact match. So if you're wondering, well, wait a second, why couldn't you say 11.11.11.11 or 11.11.11.0 and make it a /32? Well, because then we'd be trying to advertise that as a host route, and that's not going to work, right? So again, the key takeaway here and what ties back into this PILE activity, challenge 12, is that it has to be an exact match, or we're not going to be able to have BGP originate that information for us. And so here on HQ1, we're properly configured and we're advertising that public space. And in fact, we're using that, right? We're using port address translation, or PAT, to basically use that single address, and we're using the port combinations for TCP and UDP in order to facilitate the conversations that are going to be taking place. All right, so that gives us about 65,000 connections that we can track outbound. All right, so that is the HQ1 router. So now let's confirm over here on HQ2 that everything looks the same. So we say do show run section router BGP, right? And so you can see we're advertising, we're picking one of those addresses off, and we're making it a /32. So do show run include NAT. And is that the address that's being used for NAT? It is. And we can clearly see that here, that this is part of the NAT address pool. And again, the net mask is a /30, but again, we're only using a single address. And so here's where it gets interesting. So I'm going to go ahead and say do show run include route. Now, when we look at the route, what do we notice about the route statement to null 0? And I'll discuss the null 0 component here in just one second. But what do we notice about that advertisement? Whoops, I should say this static route. When we look at the NAT statement, when we look at the network statement, right? Do we have a network statement that's an exact match to what the static route is? So here we have a /32 as the network mask in our network statement in BGP. However, what is the actual static route to null 0 defined as? Exactly, it's defined as a /28. So is BGP going to advertise this address space? No, it's not. Right? We just saw that. It has to be an exact match. So we've got a couple things that we could do here when we take a look, and let me clear that out. When we take a look at what we've got. So we clearly know that either the network statement needs to change, or the static route statement would need to change. So when we look at HQ1, what did we have? Well, the static route that we created was a /32, right? And then, oops, sorry, and then that /32, sorry about that, it just timed out on me. And that /32 matches the network statement. So again, we could change the network statement to match the static route, or we can change the static route to match the network statement. And in this case, we're going to change the static route here because, again, this is showing me that this is a /32. And so that's what we'll do over here, because the network statements are both referencing /32. So let's go ahead and do this. Where are we at here? So let's exit out of the BGP configuration, and we're going to say no IP route 209.165.200.248. And this is put in here as a /28 with a 248. And it's going to null 0, and we're going to say IP route to 209.165.200. Actually, is it 248? It's supposed to be 250. Yeah. Okay, so yeah, that was even the statement itself was wrong. So it should be 250.200.250, and again, we need a exact match, and we're going to say null 0. Now, there's a couple reasons that we're doing this. And why do we send, or why are we stating null 0 at the end of that static route? Because basically what we're saying is any traffic that is not an exact match for that static route, it should be sent to null 0. Again, we don't want to be advertising in LRI that we actually do not have reachability to, because then we become a transit area and we've got traffic coming through us that shouldn't be coming to us, right? And so that's what that null 0 statement is for. And you see this in IGP quite often. In BGP, the use case for it is typically when you're doing an aggregate, right? Or that's the BGP speak for summarization, right? When you're trying to advertise a summary. Well, here we're not. We're just creating it, and we're saying that anything that is not exactly meant for that route, it's going to get dumped into null 0, right? So it's just a safe thing to do. And that's what the null 0 route is. Same thing in the IGPs, right? When you're advertising a summary and maybe one of the component routes is not a route that you have, you want that traffic, if it can't find a more specific match, to simply go to the bit bucket and be dropped. So now we've got a match here with our static route as well as the network statement. And so now when I say do show, and let me unhighlight that, do show IP BGP neighbor 209.165.200.5 advertised routes, now take a look at what we're advertising, right? So now our public address space off of this router is being advertised. Let's come back over to PC1 here, and let's get logged back in and get into privilege exec, and let's say ping 209.165.200.129, and now we have connectivity out. If I was to trace 209.165.200.129, and we should have done numeric there. All right, although it went rather quickly. So, or actually, it actually killed it when I did the Control-Shift-6. And so now we have reachability all the way out. So the failover now is working. And again, basically what we had was a network statement on HQ0 that was not an exact match for the static route that had been put in so that we could originate that in LRI. Now, that's not the only way to originate it, right? So, and we've talked about this in class when we were going over Leonard's question on the solution for this as to why is it that we need to have, let's come back to HQ0, why is it that we have this static route to null 0 and then a network statement? Why is it that we're doing it like this? And again, you don't have to do it like this. So an alternative way to do this is we could simply redistribute this NLRI into BGP, right? And so that's another way to do it. And if I were to step back over to the command line here on these Cisco 1841 routers, if I were to withdraw, let's go ahead and say no network 11.11.11.11. And again, remember we saw it over here. I'm sure we've had the withdraw already, and there it is, right? So the NLRI is gone for 11.11.11.11. So what if I wanted to get that NLRI into BGP? Well, what is it? It's a connected network. It's a loopback address. So I can withdraw the network statement and then do it like this. I could create a prefix list, and we'll just say IP, and let's jump out of here real quick. Say IP prefix list, and we'll just call it loopback1 is I think the loopback address. Yeah, loopback1 sequence number 5, and we're going to say permit 11.11.11.0/24, right? And then we're going to do a quick route map. Whoops. So we'll say route map loopback1. We'll keep everything caps here. Loopback1 permit 10. And then we're going to say match IP address prefix list loopback, and I keep doing the lowercase o there, loopback 1. So now if I was to go into router BGP1 and I was to say redistribute connected route map, and again the route map is referencing the prefix list, and so the only thing I should be redistributing here is that loopback 1. And then to simply say route map, or I'm sorry, yeah, route map loopback 0. So let's say do clear IP BGP star out. And so I could originate that NLRI by redistribution, and we should see the 11, 11, 11, 11, and we do, right? And there it is. And so that's another way to originate that NLRI. But again, the convention that you use, it's going to depend on what you're familiar with and what use case it is that you're trying to solve. So, but that's how you would originate NLRI. So let's get back to the PILE exercise here, and let's take a look. It says carrier must have access to all network devices via telnet. Okay, we've got the, and actually I should probably bring the interface back up here on HQ1 as I just looked at that, CISC0, and let's go config, or Ethernet 02, sorry. Interface Ethernet 02, and we'll say no shut and bring that interface back up. And then let's pull the scenario back here. All right, so we were testing ISP connectivity, so that's good. So Carrie noticed that a user from PC3 seems to be accessing the branch router via telnet. This is not acceptable. Fix this issue in a way that PC3 still has connectivity to the internet and can ping branch end devices, but cannot access any of the routers or switches via telnet or SSH. Okay, so this is probably, and again, so now it's kind of the shoot from the hip here approach. When I'm reading this, I'm just thinking to myself that it's not transport input anywhere, because what we're saying here is PC3 still should have connectivity to the internet and can ping branch devices, but PC3 specifically should not be able to access any routers or switches via telnet or SSH. All right, so let's see what PC3 can do right now. So if we come over here to PC3 and we're logged in, and it says that we can telnet, and I need some addresses here real quickly, which are typically in the job aid section. And there's that branch router. Let me write this down so that I don't have to come back to it. So we're going to be looking at 10308, 10308, and that is the branch router. And then we'll pick a random one. We'll go to the HQ. So 10.1.0.7 and 10.2.0.7. And I'm just making a quick note of those. All right, let's see if I can telnet to 10.2.0.7. And it looks like I can. CISCO. All right, so I can get logged in there. Can I get to the branch router, telnet to 10.3.0.8? All right, connection refused. How about telnet to 10.1.0.7? Can I get to HQ1? No, connections refused. So what's interesting is when telnetting around, right, we telnetted initially to HQ2, and I get in, but on HQ1 and the branch router, I don't. So let's take a look here at do show run, and let's begin. Whoops, and we'll begin at line con. And what I'm doing is I'm coming down. I want to take a look at the VTY line configuration. And so as you can see here, we've got an ACL that has been applied, right? Access class 10 in. So if I was to say do show access list 10, and there it is. So it's permitting 10.0.10.0 and then denying everything else. And really the only reason to keep that statement in this ACL is to see how many matches you're getting, how many hits you're getting. Because remember, at the end of this ACL is an implicit deny all, right? So, but when I do this, I'm going to get a list of the matches every time someone's trying to telnet in, and being denied. So what should happen if I'm the 10.20 space, I should be able to come over here to PC2, who I'm guessing show IP interface brief. Nope, 10.0.10. I guess PC3 is 10.0.20, show IP interface brief. Okay, so PC3. So let's try that telnet again to 10.1.0.7. And if I were to do this a couple times, you can see we're getting connection refused, connection refused, connection refused. And the reason I'm doing this is that when we come back over to HQ1 here and we say show IP, or I'm sorry, show access list, you can see we've got 12 matches. So you could quickly determine whether or not someone is actively from this 10.0.20 subnet if they're actively trying to hack this router. Hack this router. Okay, so that's the ACL there. Let's take a look over here and say do show run and begin line con. And again, we want to take a look, and you can see that we have an ACL here, right? And let's take a look and make sure do show access list 10. And so again, it's permitting 10.0.10.0 and denying everything else. All right, so that looks good. It looks the same as the other one. Let's check out, where else did we go? We went to the branch router. All right, so we can't get to the branch router. I guess we can try from HQ2 here. Let's see if HQ2, if I was to say show access list 10, I'm assuming that this access list is everywhere. All right, so now we've got an access list here, and this is just a larger range, right? It's a /16, and I'll bet you that we can telnet over to 10.3.0.8 is typically how we get over there, and we can. All right, so now we're on the branch router CISC0, and let's say show access list. Again, I'm assuming that this ACL is going to be the same ACL. And so then we see we've got the permit here, right? And then we've got the deny for the 10.0.20, and then we've got a permit for 10.3.0, and this is going to be, this is what's allowing us to connect to the branch router from the HQ router, is because, or HQ2 I should say, because on this HQ2 router, it's the outgoing interface, which is that 10.3 interface that we're using that's going to be sourcing our telnet connectivity. And so let me reread that part of the scenario again really quick. A user from PC3 seems to be accessing the branch router via telnet. This is not acceptable. Fix the issue in a way. And so when we're looking at this and we compare from the HQ2, oh, there it is. Okay. So, and that, boy, that I went right by that. So when you look at this, when you take a look at the ACL here, right, this first ACL, which says it's permitting 10.0.10, and I made the terrible assumption when I looked at that it was going to be this /16 wildcard mask. And it clearly is not, right? And even if it was a /16, we'd still have the same problem, because, let me take a look over here. HQ0 is also a /16. So hold on a second. Maybe that's not the problem. So it's not supposed to be accessing it via telnet. I need to read that again. Boy, this is a confusing one. A user from PC3 seems to be accessing the branch router via telnet. This is not acceptable. Fix this issue in a way that PC3 still has connectivity to the internet, can ping the branch end devices, but cannot access any of the routers or switches. So let's confirm PC3, show IP interface brief. So this is 10.0.20, right? And I'll bet it's a /24, show run interface Ethernet 00. Right. So this is a /24, and if it can get to, can we telnet directly there? 10.3.0.8. Okay, we can't telnet directly there. So it's got to be going to HQ2 to make that access. And so here's what I'm looking at. I'm trying to figure out, because it's got to be one of these ACLs, right? And so this is sort of the shoot from the hip. So when I'm on the branch router, you can see that it's allowing... Oh, and I apologize. I'm looking at this backwards. It's /24. So it's allowing the 10010 as a /24. It's denying the 10020 as the /24 and permitting the 103 as a /24. So that's how we're able to get in. And then from HQ, okay, so that is going to be the problem. Is that statement right there is our problem. And so here's, and I apologize, boy, some of these troubleshooting, especially the access lists, get me all tangled up and turned around. So what are we permitting here? We're saying that we're permitting 10.0.0.0, but it's a /16, right? So that means that any prefix that comes in that begins with 10.0 is going to be allowed in. And we already know that 10.0.20 is going to be in this range, right? So 10.0.20 falls within this range that's being permitted because of the wildcard mask. And the only way for PC3 to get to the branch router, it can't get there directly, right? Because we're permitting, and then we've got the correct deny statement. And the deny statement here is accurate. This is correct. However, we go in numerical order, and this permit is allowing that traffic through to the HQ2 router so that then the user at PC3 can telnet over to the branch router. So we need to block PC3, and what we're going to have to do is change, and it's on HQ2 where this change is going to have to take place. And let's exit off of the branch router. Let's get into global config. And let's say IP access list and standard 10. We're going to go ahead and say no 10. And then I'm going to say 10 permit. And our permit would match what we've seen before, right? 10.0.10.0 and 0.0. What are we using? 0.255, right? And so that's what we would have when I say do show access list 10. And we can see that that matches with the other ACL, right? A little compare and contrast here between the ACLs on the different devices, the branch router, which is denying that traffic, and the HQ2 router, which wasn't, but now should be. So if I come to PC3, you can see that if I try to go to 10.3.0.8, the connection's refused. If I try to go to the HQ2 router that I'm now drawing a blank on the IP 10.2.0.7, so if I come here now and say telnet 10.2.0.7, we should get connection refused, right? And so let's generate quite a few of those. So connection refused by remote host, and we know the reason for this, right, is it's now being denied. It's not being allowed by the first statement in the ACL, right? It's now being denied by that first statement. All right, so that is, and let me one more time double check that scenario, because they make this reference to Carrie must have access to all network devices via telnet. So she, oh, right, okay. Yeah, this statement here was throwing me early on because it's here, but it's in this internet redundancy section. So again, what they're saying here, Carrie must have access to all network devices via telnet. So she uses PC1, and why is that? Because PC1, I'll bet you, falls within the 10.0.10. And let's check that out. We get into PC1, show IP interface brief, And you're right, 10.0.10.2 is the address, so that makes perfect sense when we look at the scenario as to now why this statement is here. But really, where should that statement be? Ideally, we would want that statement to be down here, and that would give us a little more information as to how to approach this problem, right? So some very interesting scenarios and definitely some good conversation. All right, well, this is going to wrap up the tutorial and solution set for Challenge 12, and this is the fifth and final troubleshooting scenario for the PILE Accounting or PILE Forensics, PILE Forensic Accounting Ltd. All right, thanks for watching, guys, and I will see you on Thursday night.